Okay, for the next video, finishing off the sort of biochemistry component of these videos, though we'll return to a lot of biochemistry later when we do cell biology and we look at respiration and photosynthesis. We're just going to look here at an intro to enzyme kinetics. So pretty much we're just going to look at the meanings of the values Km and Vmax, so they're really commonly encountered parameters in enzyme kinetics in modeling the activity of enzymes, and able to construct simple graphs for an enzyme assay. So pretty much what I'm going to focus on in this video is there's two types of graphs you need to learn about, and they both look pretty much exactly the same, and they both look like this, except they have different things on the axes. So they have this curve which starts out pretty steep, and then it sort of curves off and approaches a limit. And there's two instances where you see this curve when you do enzyme kinetics, and we'll have a look at each of these graphs. So I've recreated the graphs here. So let's have a look at our first graph. So on our first graph, what you get this graph when, say, you take a test tube full of substrate and an enzyme, and then somehow you monitor the change of substrate into product. So you monitor amount of product, concentration of product, right? So on the y-axis there's concentration of product, and that's over time. So over, say, 2 minutes we measured the change in product, and at first we have a pretty rapid build up in the amount of product along this line here. So along here the enzyme's catalyzing the substrate to be changed into product, and that's roughly, that's roughly a straight line, right? So that's roughly a straight line there, and then slowly the rate of reaction sort of teeters off, and we have the rate getting lower and lower until the rate becomes almost zero, or reaches pretty much zero. And the reason for the rate sort of becoming lower and lower as the reaction progresses in time is the fact that we discussed that the rate of reaction is dependent on the concentration of the reactants. So the enzymes, by definition, enzymes aren't used in the reaction, but the substrate is. The substrate is changed into product. Because substrate plus enzyme goes to enzyme substrate complex, goes to enzyme plus product, right? So the enzyme is always regenerated. However, sorry, the brightness just screwed up there. So the enzyme is always recreated at the end of the steps, but the substrate is lost. So over time, as we lose the substrate, because the rate is dependent on substrate concentration, as we lose substrate from our test tube, the rate becomes lower and lower until there's no substrate left, and it's pretty much all being catalyzed into product, so the overall rate is about zero. So that makes sense. This initial rate here, so the part where it's pretty much a straight line, that's called the initial velocity, or V0. So the initial velocity of it is pretty important, and that's what the next graph is off. So this process here, putting the enzyme and substrate into a test tube and measuring the initial velocity V0, it's one of the experiments. It's part of an enzyme assay. So in an enzyme assay, what you would do, you'd run this 10 times for different substrate concentrations, and what you do, you'd record the initial velocity, the V0, for each substrate concentration. So then you generate this graph, and so down the bottom you'd have details for different substrate concentrations. So say we did an enzyme assay with 100 different experiments of those individual test tubes from before, and we had for each substrate concentration we had different V0s following a trend like this, right? So you plot that out, and up here is the initial velocity, so V0. So on our y-axis we have the initial velocity of the previous graph, and then along the x-axis we have the substrate concentration for that actual experiment. And again we see the same trend. We see that there's initial sort of straight line segment here. I'll do it in red if I can. So there is sort of a straight line, and then it curves off and it approaches a limit as we reach higher and higher substrate concentrations. And the reason for this is the fact that as substrate concentration increases, we only have a limited amount of enzymes. So say we have 2 enzymes. When we have only a small amount of substrate, one of them is going to be bound at any one time, and then that will convert into product. And by the time that conversion's happened, this one might be bound, and then this one's going to be free, sort of thing. But if you have a very large amount of substrate, all the enzymes are going to be bound by substrate and going to be sort of working as fast as they can, as hard as they can. They're all going to be working. All the enzymes are going to be working. So you're going to approach this maximum efficiency where all the enzymes are occupied, and so they can't really go any faster. Whereas at low substrate concentrations, only say half were occupied. So by increasing substrate, you were getting sort of a linear trend, but then it approaches a limit as you approach larger and larger substrate, as you approach the limit, infinite substrate concentration, because as you approach infinite substrate concentration, all the enzymes are occupied, and so the enzymes are working as fast as they can. So the rate can't really, the initial rate here can't really increase anymore, no matter how much substrate you add after a point. And the limit it approaches is given a special name. So it's called the Vmax. So this is the maximum velocity that the enzyme can there we go. The maximum velocity that the enzyme can reach, and it's an intrinsic measure of the enzyme efficiency, of the efficiency of the enzyme to catalyze the step from substrate and turn it into product. So it's sort of a measure, Vmax is sort of a measure of the efficiency of the enzyme and how fast it can go. Now there's another important parameter, and I'll try and put this one in black. So if Vmax is like 10, in like, I'm just making arbitrary units, but if you go down to 5 on your scale, and you come across, and when you hit the curve, you drop down to the x-axis, that gives you what's called a Km value. Now Km is the Michaelis constant. It's named after the guys who theorized this behavior of enzymes called, and their names were Michaelis and Menton. When I say guys, Maud Menton was actually a woman and a pioneer biochemist. But these two scientists, Michaelis and Menton, they theorized this trend of enzyme activity and then proved that it was true through experimentation. And this Km value, which is the substrate concentration at which half of which the enzymes in the assay are working at half of Vmax. That Km is a measure of enzyme affinity for the substrate, so how tightly it binds to the substrate. And that might not seem totally intuitive now, but as you go forth and do higher level biochemistry and do some of the mathematics and modeling behind this that Michaelis and Menton came up with, you'll see that it's actually quite a good model. But we won't go into that here. It's just sort of an overview to give you a bit of an intro into where some of these assay curves come from, what Vmax is. It's the maximum velocity that an enzyme can reach. The Vmax is a measure of efficiency, and then there's Km, and Km comes from the substrate concentration at which the enzyme is working at half of Vmax, and that is a measure of enzyme affinity for the substrate. That's pretty much what you need to take from this. Km might seem a bit out of left field at this point in time, but as you go forth, it will become clearer. It's just something you need to remember. It is worth noting, actually, increasing Vmax intuitively, it's an increase in enzyme efficiency. Actually, increasing Km it's a decrease in enzyme affinity, whereas so increasing Km indicates a decrease in enzyme affinity for the substrate. That's just something you have to keep in mind if you ask questions about Km or Vmax. but for most introductory biology courses, it's not such a huge topic. You just get this sort of intro into what some of the meanings of some of these terms are. So that sort of finishes up for biochemistry. We'll be moving on in the next video to cellular biology.